Welcome back, viewers. In the last video, we discussed the preparation of haloalkanes and haloarenes that was given as a part 3 video. I hope you liked that video. In that video, we have discussed how the haloalkanes are prepared by using alcohols. In that one, first one, already I told it is prepared by treating halo acid, that is nothing but HX. In the second one, it is also prepared by using phosphorus halides like trihalides and pentahalides. And the third one, it is also prepared by using thionyl chloride, and also it is prepared by using sodium bromide and concentrated H2SO4. In that one, I told you to remember some important concept of called as a Gru's process and also called as a Lucas reagent. I repeat once again, Lucas reagent is a mixture of anhydrous zinc chloride and concentrated HCl. In this today's video, what we are going to discuss is the continuation of preparation of haloalkanes. That continuation of preparation of haloalkanes we also call it as by alkanes. In this video, we are going to discuss how it is prepared by alkanes and how it is prepared by alkenes, and special one, very important reaction by halogen exchange method. These are the three important features or reactions which you are going to study in this today's class. One by one, let us begin it. How the haloalkanes are prepared by simple using alkanes. This is already in the PUC first year. You already prepared this, already studied this. Therefore, this reaction, I think for you people, it will never be a difficult part. Therefore, my heading I will write today's one. That one, it is prepared by alkanes. You know, alkanes, they have a general formula of CnH2n plus 2. The first member of alkane is a methane. I want to convert methane into haloalkane, means very simple. Look into this one. I take CH4, that is a compound called as a methane. It contains 4 hydrogen. 4 hydrogen it contains, means all the hydrogen can be eliminated. I take in presence of chlorine. Wherever chlorine comes, his friend, that is a light, will come. Light is already written with a symbol H mu, because you already know E is equal to H mu. This is a light symbol, right, equation which was given by the Einstein. Therefore, they use E is equal to H mu. H mu here symbol stands for light. You know, 2 chlorines are there. One chlorine will eliminate 1 hydrogen. Therefore, the product you are getting is CH3Cl plus another chlorine combines with the eliminated hydrogen and comes out in the form of HCl. This is how the compounds are obtained. Here the compound name is methane. Therefore, 1 chlorine is inserted. Therefore, the name of the compound becomes what? Chloromethane. This is how the reaction can also be carried out. Now, I go with the second one. Second example I will take. Then I will take ethane. Ethane formula, you know, CH3 and CH3, or also can be written as C2H6. Here also I will take a chlorine. Then I treat with a light. Wherever chlorine is there, light will come. 1 chlorine combines with 1 hydrogen and eliminate as what? HCl, gone. Then another chlorine goes in place of a hydrogen, thereby giving CH3, CH2Cl. If we eliminate the hydrogen from the left side of CH3, then also same product. If we eliminate from the right side of the CH3, then also you get the same product. Therefore, methane and ethane will give only one compound. Therefore, this name I will write it as ethane. Then the product I will also getting it as what? Chloroethane. I hope these 2 reactions you don't have any difficulties. Then moving on to the next one, I take CH3, CH2, CH3 plus Cl2. Then again I treat with H mu. Carefully observe this reaction, which is quite important. Now, we have 3 different type of hydrogen. One hydrogen we have CH3, another hydrogen in the form of CH3, another hydrogen in the form of CH2. Means here there are 2 different hydrogen. One CH3 hydrogen and another one is CH2 hydrogen. And make sure these 2 hydrogens, they are one and the same, because both are CH3. Another type of hydrogen is what? CH2. Same reaction. Chlorine will eliminate 1 hydrogen from the CH3, thereby giving CH2Cl plus CH2 and CH3 as it is. I hope you don't have any difficulty over this one. Now, this compound I will write it as 1, 2, 3. Therefore, the name of this compound becomes chloropropane. Because 3 carbon atom are there, I will write 1 chloropropane. Here also I will write it as propane only. So propane will give 1 chloropropane. This is the A product, right? Now what I have to do? There is one more chance. What is that chance? It can also be eliminated from CH2. If CH2 is eliminated, then I get CH3, CH2, CH3 plus Cl2, then again H mu. Right. Now what happens? Chlorine eliminated from CH2, then you will get CH3, CH3. Now hydrogen is eliminated from the second carbon atom. You get second carbon atom chlorine bonded. Therefore 1, 2, 3 if I write the name, this becomes a 2-chloropropane. Is there any change in the reactant? Reactant remains the same, but the product they are differing. Here also number of carbon atom remains the same, but the position of chlorine differs. In the first case it is at A. In the first case, this is I will take it as a B. In the first case it is at first position. In the second case it is at second position. The compounds which differ by the position of the functional group or substituent, such compound you also call it as positional isomers. That's why remember the preparation of alkanes by halogenation. Halogenation means you treat with chlorine or bromine. When you treat any alkane other than ethane and methane, if you treat any other alkane like propane, butane, pentane, hexane, heptane, higher alkanes with a halogen like chlorine and bromine, you always get isomeric compounds. 1 or 2 compounds you get, and those isomeric compounds always in the form of position isomers. This is what you need to important for some of the competitive examination. There you have to identify how many different types of hydrogens are there, so that your product becomes very, very easy. For your understanding, I will not stop over here. I will take one more example. Let us verify how many product that compound will give. We take the another example. I will write over here. Try to identify how many different types of hydrogens are there. So many different types of a product it will be forming. Now I take butane, CH3, CH2, CH2, CH3 plus Cl2. Then I treat in presence of H mu, that is nothing but a light. Now your job, no need to predict the product. First you identify how many different types of hydrogens are there. With your permission, CH3, they are one and the same. Therefore, this is a one type of hydrogen. And CH2, these are also same. This is a second type of hydrogen. Therefore, the type of hydrogen they are existing in this butane are 2. Therefore, I get 2 products. This is how you have to identify. Therefore, I will write the name as butane. Let us verify. In the first case, if CH3 is converted, then the compound you are getting is CH2, 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 CH3, and in the first position you get a chlorine. Now the name is butane. This compound name is 1-chlorobutane, correct? Now what is the second compound? It is eliminated from CH3. Now it can be eliminated from these two. Any of one will be eliminated. Therefore you get CH3, CH, CH2, CH3, then you get Cl. This is a 2-chlorobutane. Now see, I told 2 different hydrogens were there, therefore you are getting 2 different products. Again these 2 products, their compounds molecular formula is the same, but the position of a substituent is differing. Therefore these are also called as a positional isomer. This is how the compound has to be remembered. Now one again reaction I will write over here, so that again your learning becomes more effective. This is very, very important for your competitive examination also. So many questions are coming from this one in the preparation of haloalkanes by using alkanes. Now I go with the next carbon atom. Butane is over. I will take pentane. Pentane formula you know, CH3, CH2, 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 CH3. Now try to identify different type of hydrogens. CH3, these are one type of hydrogen. CH2, these are another type of hydrogen. Center CH2 is a different hydrogen. Therefore, number of hydrogen becomes what? 3. And also product formed will be also 3. How it is there? If you convert CH3 into CH2Cl, this is A product. If you convert CH2 into CHCl, that is B product. If you convert third also, means that is also C product. Means you get 1-chloropentane. Second you get 2-chloropentane. Third you get 3-chloropentane. Therefore pentane will give 3 compounds which are different depth of hydrogen. This is all about by alkanes. I hope you don't have any difficulties. Moving on to the next one, that is by alkenes. Very, very important also you have to remember here. Again some concept need to be discussed which were there in the PUC first year syllabus. This is all the revision again that is there for same second year also, and it is also important for your examination also. I write alkene and I treat them with hydrogen halide. Means we'll write the heading second method, that is by alkenes. You know alkenes, they contain double bond, carbon-carbon double bond. Now I write CH3, CH double bond CH2, I treat with HCl. Now here I can take HCl or you can even take HBr. Then what I do, I carry out the reaction. Now you know HCl will split as H plus and Cl minus. Easily you can identify here the negative part of adding molecule is what? Cl. Now this is unsymmetrical alkene. Unsymmetrical means if you cleave the double bond or if you break the double bond, there are two carbon atoms on the left side, whereas there is only one carbon atom on right side. Such alkenes are also called as unsymmetrical alkene. Now this alkene I will name it as 1, 2, 3. This is also called as propene. Now you see what will happen. Negative part of adding molecule in unsymmetrical alkene goes to that carbon atom containing least number of hydrogen. According to which rule? That rule already you know. Call it as Markovnikov's rule. Right? You know, negative part of adding molecule, which is that adding molecule Cl, will go to that carbon atom in unsymmetrical alkene containing less number of hydrogen, means it will go to CH. If it goes to CH, what is the product you will get? CH3, CHCl, correct? Now pi bond shifts on CH2, then it becomes what? CH3. What is the name of this compound? It is a 2-chloropropane. This product is in accordance with which one? This product is in accordance with Markovnikov's rule. Remember, this product is in accordance with Markovnikov's rule, which says negative part of adding molecule goes to that carbon atom in unsymmetrical alkene containing less number of hydrogen. What I do, same reaction I will carry out in presence of H2O2. I will write over here. Same reaction, CH3, CH double bond CH2 plus HCl or HBr, right? In presence of H2O2, peroxide I will take. Here also H plus Cl minus. Now if you take in presence of a peroxide, this rule is also called as anti-Markovnikov's rule. This rule is also called as anti-Markovnikov's rule. According to this, negative part of adding molecule goes to that carbon atom in unsymmetrical alkene containing more number of hydrogen where double bond is present. In such a case, I will write CH3, it will not come to CH2, sorry CH, it will go to CH2, means pi bond shifts on CH, it becomes CH2, then it becomes CH2, Cl, this is 1-chloropropane. See the difference. Reactant is same, but product is different. This is accordance with Markovnikov's rule. This is in accordance with anti-Markovnikov's rule. This effect is also called as a Karsh effect, or it is also called as a peroxide effect, and the rule is called as anti-Markovnikov's rule. I hope you all have discussed or studied this in the PUC first year. Therefore, you don't find any difficulty over there writing the product. And these two rules will work only when there is a presence of unsymmetrical alkene only. Remember this. When unsymmetrical alkene is there, negative part will goes to less number of hydrogen atom, and in anti-Markovnikov's rule it goes to more number of hydrogen atom. Therefore, coming back to the next one, how it is prepared by halogen exchange method, third method, which is therefore very important for CBSE examination or State Board of Karnataka students. Very important, frequently asked question, that is by halogen exchange method, that we will discuss. I will write the heading so that that heading itself carries a lot of important work that you need to remember. Therefore, I will write it as by third one, I will write it as by halogen exchange method. See, whenever they ask the question halogen exchange method in the Karnataka State Board examination, there will be definitely sure short 2 mark question which are going to come. Under halogen exchange method, you study 2 reaction. One reaction I will write it as, first one, I will write it as a Finkelstein reaction. First reaction I will write it as what? Finkelstein. First I will write the reaction so that you can explain that reaction. Self-explanatory reaction will also carry the marks. On your own you will explain. That is very simplest reaction. Now you see, I will take Rx. You know Rx is nothing but alkyl halide. This X may be Cl and Br. This R group is also called as alkyl group. I treat with sodium halide, that is sodium iodide, specific. Here you cannot change it. I never become Cl, Br and F. It is specifically sodium iodide, and I will carry out in presence of dry acetone. This acts as some medium or a catalyst to carry out the reaction. Now you see, I have taken alkyl halide and sodium iodide in presence of a dry acetone. Halogen will exchange their place. Means X will go to I position, I will come to X position. See how the reaction happens. X will combine with sodium and I will combine with R. Then what is the product you are getting? You are getting Ri plus NaX. Can you name it? What is I stands for? Iodide. Therefore, this compound I will also write it as alkyl iodides. Remember, very easiest 2-mark reaction. Actually, nothing is there. How to explain this reaction in your words? You see, when alkyl halides are treated with sodium iodide in presence of a dry acetone, we get alkyl iodides. This reaction is also called as which one? Finkelstein reaction. Very easiest reaction. Second I will take. Second one. Now, same type of reaction we call it as a Schwarz reaction. This reaction is also very, very important 2-mark question. Again, I will not change. I will take Rx as the same thing. Plus, now I will not use NaI. If I use NaI, Schwarz reaction again becomes what? Finkelstein. I have to change this. I will take Ag of silver fluoride I take. Specifically metal fluorides. Not only silver, you can take mercuric fluoride also. Any metal fluoride which will work. I will carry out the reaction, you know. Halogen exchange will take place. X combines with Ag, F combines with R, then compound you are getting is Rf plus NaX. Same thing, if I want to explain Schwarz reaction, when alkyl, remember not aryl, benzene should not be there, alkyl halide combines with silver fluoride and they will give alkyl fluoride along with the elimination of NaX. I will write it as alkyl fluorides. See, very easy. You know, if I do this one, everybody can explain this reaction. Is it so difficult for a 2-mark to be written? One reaction, if you write, you will get 1 mark. Then if you explain the same reaction, you will get another mark. See how I explain Finkelstein. When alkyl halide reacted with sodium iodide in presence of dry acetone, we get alkyl iodide. This reaction is also called as Finkelstein. What is there? There is no differentiation and integration in this one. Very easiest. Similarly, when alkyl halide treated with AgF, we get alkyl fluorides along with the elimination of NaX. This reaction is also called as what? Schwarz reaction. So easiest reaction it is. Right? That can be asked for how many marks? 2 marks. That is all about halogen exchange method. Now we will solve some examples and we will wind it up. Remember Finkelstein and Schwarz reaction. Finkelstein means NaI, Schwarz means AgF. This you should remember so that the reaction becomes very, very easy. The first example I will take CH3Cl plus NaI, sodium iodide, then dry acetone, correct? Dry acetone. This I will write it as methyl chloride. Methyl chloride. Then what will happen? Cl goes their side, iodine comes this side. Then what will happen again? You get CH3I plus NaCl. What is the name of this one? Methyl iodide. Which reaction this is? This is Finkelstein reaction. Second I will take CH3Cl plus AgF. Then what will happen? Cl goes that side, fluorine comes this side. Exchange, halogen exchange. Then what is the product? You get CH3F plus AgCl. Then what is the name again? Methyl chloride. Very easiest, chloride plus here AgF, CH3F. Then it is nothing but a methyl fluoride. See how easiest reaction it is for 2 marks. Therefore, in this today's class, we all have discussed how the haloalkanes are prepared by alkanes. I told methane, ethane will not give multiple product. It will give only one product. Multiple product starts from propane. Propane will give how many product? 2. Pentane will give, right? Butane will give 2. Pentane will give 3. And those product are also called as isomeric product. Which isomer they are? They are position isomers. Second, we have discussed from alkene. There are 2 rules I have given. Which are those 2 rules? One is Markovnikov's rule. Another one is anti-Markovnikov's rule, or also called as peroxide effect or Karsh effect. Then halogen exchange method, 2 reaction we discussed. Which reaction? Schwartz reaction and Finkelstein. All these are connected to my previous video, that is part 3. If you haven't watched that one, I will provide a link over here. Please do watch that video, comment and share. I hope you all have liked this video. With this, we conclude the preparation of haloalkanes, and only haloalkanes. We are not come for the haloarenes. So with this, I will wind up the preparation of haloalkanes. All method it completes. So that in part 4, we all have discussed the preparation of haloalkanes. In the part 5 video, we will discuss the chemical properties of haloalkanes. There are some important reaction, that is a nucleophilic substitution, that I will take it in my next part of the video. I hope you watched this video and you liked this. Please do comment and share. Thank you.